In this video, I'd like to help you understand Babylonian numeration. The Babylonians used base 60. That means their digits are 1 through 59. They don't have a 0 like we do. So, in order to make their digits, they just had two symbols, a 1 and a 10, like a little T and a little V. You can make any number you want, any of their digits 1 through 59 using these symbols. Here are some examples. 23 is 2 10s and 3 1s. 6 is 6 1s. 40 is 4 10s. And 59 is 5 10s and 9 1s. To write numbers greater than this, you have to use the concept of place value. Their place values are 1, 60, 60 squared, 60 cubed, etc. And their symbols have different values based on the position relative to place value, just like ours. For example, in base 60, 135 is 2 times 60 plus 15 times 1, which is represented like this. 2 60s plus 15 ones. You also read from right to left or left to right. It just sort of depends on your perspective in the same way that we do with our number system. Here's another example. 22 times 60 squared plus 3 times 60 plus 30 times 1 is 79,410. In Babylonian, that is 22 times 60 squared plus 3 times 60 plus 30 times 1. 3 10s, 3 1s, 2 10s, and 2 1s. This all adds up to our base 10 number of 79,410. But suppose you started with 79,410 and you wanted to go the other direction. That's what this video will help you understand. So to start with, we have to look at the Babylonian place values. 160 is 60 squared, which is 3,600, and 60 cubed, which is 216,000. You can keep going higher by multiplying by 60, but we don't need to for this example. So you determine the biggest place value that goes with your number. 79,410 is bigger than 3,600, but less than the next place value up. So we start with 3,600. Then you divide your number by this biggest place value. When you divide your number 79,410 by 3,600, you get 22 and some decimal that it turns out we don't care about. This tells us that 79,410 is 22 times 60 squared, that's 3,600, plus some more terms. And in order to determine the more terms, we need to get the remainder, and then we will repeat the process. So just to review about remainders, this easy example, we know that 9 is 2 times 4 plus 1, or 9 minus 2 times 4 plus 1. 2 times 4 is equal to 1. We can determine the remainder 1 here by noting that if I take 9, I divide it by 4, I get 2 and some stuff. Then I subtract 2 times 4 from 9, which gives me my 1. We'll do that again with our example. So we've already determined that when we divide our number by 3,600, we get 22 and some decimal. This tells us that 79,410 is 22 times 3,600 plus a remainder. So that means that 79,410 minus, we just move this to the other side, 22 times 3,600 is the remainder that we want. If we put this in our calculator, we'll see that our remainder is 210. This now tells us that 79,410 is 22 times 60 squared plus 210. But we're not done yet because this is not in the Babylonian place value. So 210 is greater than 60, which is our next lowest place value. So we repeat. We divide 210 by 60 and we get 3, in this case 0.5. So when we do our computation, 210 minus 3 times 60, we get our remainder of 30. Now we put that all together and we get 79,410 is 22 times 60 squared plus 3 times 60, we got that from here, plus 30, which we can rewrite noting that the place value for 30 is 1. So now notice that we're all smaller than our smallest place value of 1, and so we're done. Also notice our digits here are all between 1 and 59. If you get a digit in Babylonian that's bigger than 59, you haven't divided by the proper highest place value. Here's some other examples. 47 is 4 tens plus 7 ones. 2,473 has been converted into 41 times 60 plus 13 times 1. So in Babylonian, that's 41 plus 13. 10,821 has been converted in base 60 to 3 times 60 squared plus 21 times 1, which is a little weird because what happened to the place value of 60? You can see that that's listed here, and in the next slide we comment that there's a little flaw to the system. They don't have a symbol for 0, and so they don't really have a way to show that missing power. They would put a large gap, but sometimes it's really hard to see that there's a gap there. Here's another example to walk you through the whole process. Let's start with 1 million. Our place values in Babylonian are 1, 60, 3,600, and 216,000. We'll have the details of this in the next slides, and notice when you do your work at the end, you can always put your final expansion into a calculator and check that you've done your math correctly. So first we check our place value. 1 million is greater than 216,000. We divide by 216,000 and we get 4.6 some stuff. This tells us that 1 million equals 4 times 60 cubed, that's 216,000, plus a remainder. When we subtract that to the other side, we get 1 million minus 4 times 60 cubed is 136,000, which is the remainder we want. So now we know that 1 million is 4 times 60 cubed plus 136,000. Notice that number is bigger than 59, so we have to repeat these steps. Now we check and see that 136,000 is greater than 3,600. So we divide 136,000 by 3,600 and we get 37 and some decimal. This tells us that 136,000 is 37 times 60 squared, that's 3,600, plus a remainder. We subtract that over, we put it in our calculator, and we get 2,800 is our remainder. So now we can run that all together and we get 1 million is 4 times 60 cubed plus 37 times 60 squared, that's from here, plus our remainder of 2,800. And again, that's bigger than 59, so we keep going. So 2,800 is bigger than our next place value, 60. We divide, and we get 46 and some change. This tells us that 2,800 is 46 times 60 plus a remainder. We subtract that over, we put it into our calculator, we get 40 as our remainder. Now we know that 1 million is 4 times 60 cubed plus 37 times 60 squared plus 2,800, which we've already determined here. So that's 4 times 60 cubed plus 37 times 60 squared plus 46 times 60 plus 40. You can write that again, and notice I've put a place value of 1 here with the 40, and therefore in Babylonian I write this whole thing like this. Here's my 40 times 1, here's my 46 times 60, here's my 37 times 60 squared, and here's my 4 times 60 cubed. Notice I didn't have that gap for 0 issue here. That's it for this video. I hope it helps you understand Babylonian numeration.